Case number 23. We are going to verify this equation if this is an identity. We have the tangent squared x minus sine squared x is equal to the product of tangent squared x and sine squared x. For this, we are going to manipulate the left-hand side using appropriate operations and the transformation of tangent into a combination of sine and cosine, and possibly the inclusion of Pythagorean identities in order for us to arrive to whatever is found on the right-hand side of the equation. And if we could do that, that means we have verified this identity. We are to start with transforming tangent squared x into a combination of both sine and cosine. In this manner, we can now look into a possibility of using other processes. So tangent squared x can be written as sine squared x over cosine squared x. This is the equivalent of tangent squared x in terms of sine and cosine. This is still to be subtracted with sine squared x. Now for this meantime, we are just going to manipulate the left hand side, so no need to write the right hand side here. Next here is to combine these two expressions. Take note that our second term here is understandably over 1, and this means we are combining here rational expressions. Or similar to your fractions, when you add, or in this case subtract, two fractions or rational expressions, you are to look for a LCD, the least common denominator. The least common denominator here is just cosine squared x times 1, or simply cosine squared x. In this case, we are going to divide this by any of the two denominators, and the result will be multiplied to their corresponding numerators. So cosine squared x divided by cosine squared x is 1 times sine squared x. You have here sine squared x. Okay. Second, cosine squared x times 1 is cosine squared x. Divide 1 is cosine squared x times this. So it's a combination of the product of sine squared x and cosine squared x. Now, if you're not convinced with this process or this result, take note that if we're going to divide this, that's just the same as the first term. And if we're going to divide this, of course, cosine squared will be removed. Sine squared x is the same as your second term. To complete this, the operation will still be subtraction here. Now, if you look closely on your numerator, you can see presence of a similar term, which is a sine squared x. Right? So you could write it like this. So you can factor out sine squared x. Okay. And what happens to your first term is just 1. Okay. And then if you're going to factor out sine squared x here, you have minus cosine squared x. Take note, we factored out sine squared x of our numerator. This is all over your same denominator of cosine squared x. The question now here is, what is the next thing to do? Take note that we have here a product of a monomial and binomial, and if we're going to multiply that, you'll just return to your previous equation. What happens here is, look closely at this term, the 1 minus cosine squared x. One of the Pythagorean identities that we know is this one here. The sum of sine squared x plus cosine squared on the same angle x is equal to 1. This is a Pythagorean identity taken from our unit circle. And what's the purpose of this? If we are going to subtract both sides by cosine squared x to remove this, of course, you're going to do the same thing on the other side. We will have here an expression which is sine squared x is equal to this result, 1 minus cosine squared x. Now, we can substitute this to our sign here so that we can just simply multiply two binomial expressions, but it will get a little bit more complicated. So what we need to do here is this entire expression of binomial 1 minus cosine squared x will be converted to or transformed to this, which is just taken from this Pythagorean identity. In short, you will have here the product of sine squared x and another sine squared x, which is just the same as 1 minus cosine squared x here. This is over cosine squared x. In proving or checking for identity, you always need to remind yourselves of the end result. Your end result is the product of tangent squared x and sine squared x. Hence, you really need to establish a product. Okay? If you're going to return or stick with the second equation here, you have difference, so you're very far from your goal. If you're also going to use here 1 minus cosine squared x, which is the equivalent of sine squared x here, you will have another polynomial expression. I mean, a series of trigonometric identities that are either added or subtracted, so you're far from your goal. In short, you really need to come up with a product and no other operations here. Now from this, let us try to separate. Okay, you have here the sine squared x, cosine squared x here, and then separate here another sine squared x. And since this is under multiplication, your denominator could be 1. Okay, it's not plus or it's not cosine squared here, x here as well. You're just separating them to come up with two different expressions, because if you're going to pair it with this, you will have sine squared x all over 1. Okay, now what is sine squared x over cosine squared x? That's your tangent squared x, and of course sine squared x over 1 is simply sine squared x. With this, we have verified that we have arrived into a product of tangent squared x and sine squared x from their difference. And with this, we have verified this given identity. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.